Hey everyone, welcome back to our Python programming series. Today we are going all in with a complete guide to Python operators, fundamental tools that drive your code's logic and calculations. Operators let you add numbers, compare values, combine conditions, and manipulate data at the binary level. Everything from building a budgeting app to securing a network. In this video, we will cover every single Python operator across 7 categories. First, arithmetic. Second, assignment. Third, comparison. Fourth, logical. Fifth, identity. Sixth, membership. And as the final one, bitwise operators. Each operator will get its own example rooted in real world scenarios like e commerce, gaming, or system administration. So let's get started. Python groups operators into 7 categories. Arithmetic for math operations, assignment for updating variables, comparison for evaluating conditions, logical for combining decisions, identity for checking object identity like is not, membership for testing inclusion in and not in. In addition to that, bitwise operators for binary manipulation. Okay, let's start with arithmetic operators, which handle all mathematical operations. These are essential for tasks like financial calculations, game physics, or data analysis. Python's arithmetic operators are addition, subtraction, multiplication, division, color division, modulus, and exponentiation. We will code an example for each in an e-commerce app calculating order details. Okay, let's calculate an order. I am typing, please type with me. I'm typing items equals 3. Items equals 3. Now, price underscore per underscore item equals 50.99. For addition, I'm writing subtotal subtotal equals price price per item plus 5. Okay. For subtraction, I'm typing discounted equals subtotal. So let's say sub underscore total minus 2. For multiplication, I'm writing items multiplied by price per item, and I will assign it to total. Items times price underscore per underscore item. So for division, I am typing average price equals total divided by items. For floor division, I'm writing int average equals total floor items. For modulus, I am typing remainder equals 50 modulus items. For exponentiation, I am typing square equals items double star 2. Sorry, 2. This one. Okay. For exponentiation, I'm writing square equals items double star 2. Now I will print it as a formatted string. So let's write f and double quotes. Inside these double quotes, write results. results. Subtotal equals subtotal discounted discounted equals discounted. So let's break it. Let's break the line. Discounted counted equals discounted. So now let's say total equals total and break it again. Average price and let's type a comma. Average price is equal to average price, and don't forget the dollar symbol, and remainder equals okay, remainder equals remainder only, and square equals square. Okay, that's all. This prints a full order summary, and the plus operator added a fee, minus operator applied a discount, times computed to total, division gave a float average, floor division returned an integer, modulus found the remainder, and double star calculated a power. So let's print it and see what it will output. Here we can see the results. For each variable, let's inspect. Average price is equal to 15.99 with a type of float. Discounted is equal to 18.99 with a type of float. Int average, int avg, int underscore avg is equal to 15, the type of float. Items is integer and its value is 3. Price per item is float and its value is 15.99. Remainder is 2. Square is 9 and an integer because items was assigned to 3, so we can prove it. And subtotal is equal to 20.99 and total is equal to 47.97. So we are done here and we successfully completed our first step. Let's talk about assignment operators. Assignment operators assign values to variables or update them by combining operations. Python's assignment operators are basic assignment and compound assignments. These are perfect for counters, accumulators, or binary flag updates. We will code an example for a game stats tracker updating player metrics. So let's start and type an example for each of the operators. Let's start by basic assignment. So if you want to do basic assignment, just write, I will create an example about game stats tracker. So I will write points equals 100. So it's a basic assignment. It directly assigns what value you have typed. Now I want to add 50 points, so I will use points plus equals 50. Addition assignments. Now let's accept that player's health is 80. So let's write health is 80. Health is 80. Set health. basic assignment again, assignment. And health is dropped by 20. Health is dropped by 20. So it's a subtraction assignment. Let's say speed is 5. Let's say speed is 5 and that speed is a comment. Now players started running. I will multiply speed by 2. So player is 2 times faster and correct this as points, and player is now 2 times faster. So it's multiplication assignment. Let's set energy. Energy is 100. Set energy. And now after player ran, the energy decreased 4 times. Energy decreased 4 times. So let's say y equals 4 division assignment. Let's say integer energy equals 100. That int energy. And int energy floor division equals 3. And it's an floor division assignment. Now let's say chance equals 25. Chance. Now chance is equal to modulus equal 7. So it's an 7. So it's a modulus assignment. Now let's set power to 2. Say set power. And now let's set power to 2 and write set power as a comment and apply exponentiation assignment. So let's write double star equals 3 and type exponentiation assignment. Let's write flags equals 5. Think this one as a setting that keeps players' current settings or saved settings, and we will keep it like a binary number, and we will manipulate it like a binary number. Let's write binary 101 settings. Flags bitwise ends equals 3. So bitwise end assignment. And now let's say flags or equals 5. That flags or flags or equals bitwise or equals 3. Bitwise or assignment. Let's try XOR. So let's write flags XOR equals 5 So say let's set flags and flags XOR. Bitwise XOR equals 3. And it's a bitwise XOR assignment. Now let's shift it left. So let's say shift left equals 5. Shift set and shift it left by doing this. 1. Say left shift assignment. So 101 becomes go as it 1010. It's shifted left by 1. So let's try another thing. Shift right equals 5. Shift right 1 and shift right equals 5 and shift right let's say shift set and right shift assignment 101 to 010. As you see, it decreased because we made a right shift assignment. Shifted it right. So I will just clear the old variables and run it to inspect. Let's take a look at this. Points equals 150. So we added points 50. It became 150 from 100. Health is, let's see out, 60. So it was 80 first, but then we subtracted 20. So it became 60, right? Speed is 5. We multiplied it by 2. So speed became 10. Energy was 100. We divided energy by 4. So energy is now 25. Int energy was 100. We floor divided it by 3. So int energy became 33. Chance was 25. We performed a modules assignment by 7. And chance is now 4. Power was 2, and we performed an exponentiation assignment, so it became 8. Let's see how flags are changed. So flags was 5. After I applied bitwise and assignment, it became 1. Flags OR was 5. After I applied bitwise or assignment, it became 7. Flags XOR was 5. After I applied XOR assignment, it became 6. Shift left, it was, as you can see, 5. Left was 5. After I shifted it After I shifted it left by 1, it became 10. So its value is increased, as we can see here. For shift right is the inverse of it. So it decreased and became 2. That's all. We have successfully applied nearly all of the operators here, and we can see how their value changed. Variable Explorer provided a full stats update. Each assignment operator like plus equals ampersand equals update its variable efficiently. In a game, these operators track player progress with bitwise assignments managing binary flags for settings. Comparison operators test relationships between values, returning true or false. They are used in conditionals for decisions, like validating stock levels. The operators are equal, written, or typed like this. Let's code an example for an inventory. Okay, I'm writing stock equals 50 and minimum, let's abbreviate it like min, stock is 50. Let's write if stock is equal to min underscore stock. So if stock is equal to minimum stock, print stock at minimum. If stock is not equal to 100, print stock not full. If stock is greater than 30, print sufficient stock. If stock less than 60, write low stock. If stock greater than or equal to 50, print at or above minimum. If stock is less than or equal to 50, print at or below threshold. Let's add marks to end of this. Okay. Now, this prints messages like stock at minimum and sufficient stock. Each operator in an inventory system, these operators trigger restocking alerts or status updates. So let's run and see it. Yeah, they all printed the current status. So we can say that we can use conditions together with comparison operators in order to build a system like this one. Now let's learn logical operators. Logical operators combine conditions for complex decisions, returning true or false. Python's logical operators are and, or, and not. We'll write it and, or, not. Three different operators. So you use and if you want two conditions to be true. You use or to check if one of the conditions is true and not to check if its inverse is true or false, vice versa. So here we will see an example about user registration. But things like logical operators are crucial for scenarios like user authentication. Let's code examples for a conference registration system with a dedicated example for each operator, and let's see it. Let's say is attendee true, and this is our attendee status. And let's say has paid true if, let's write a conditional, if is attendee and and has paid prints entry confirmed, else it's just a simulation, by the way, entry is denied, or entry denied. Okay, now let's run it and see the results. It says entry confirmed because we are both attendee and we have paid. Now let's see another example. Let's say is speaker true. All right, speaker status, and has pass is false, pass status. It's a flexible entry. So let's write if is speaker or has pass prints VIP entry, else print standard entry. So here we decide if the person is VIP or standard guest. So let's run it, and it says VIP entry because one of these conditions is true. It says VIP entry. If it was false, it says standard entry. Now take another example. Let's think that a user is banned on a platform. So let's write is banned true. If not, is banned print welcome to conference websites. Let's print, and it says nothing. So user is banned. If it was false, it could print a welcome to conference website. So we have demonstrated with these simple examples. We can use conditionals together with logical operators to perform operations like this. Now let's talk about identity operators. Identity operators check if two variables refer to the same object in memory using is and is not. They differ from equal, which checks value equality and are useful for memory optimization or type verification. Let's code examples for a data processing app comparing objects. So let's say I have a data named data A equals 1, 2 equals to a list. So I call it first list. Then data B equals data A. And as you remember, it becomes the same object. And now let's write a conditional to compare them. If data A is data B. Now let's write a conditional to check it. If data A is data B, print same object, else print different different object. It says same object. Great. Is not is the inverse of it, so we don't need to demonstrate it. Now let's assign data B to another object, but with same values. Let's print it again. It says different object. If you assign them like this, or if you remember like this in the same line, they are still same objects. Yeah, so we can check identity by using it. Now, what are membership operators? Membership operators test if a value exists in a sequence, like list, string, tuple, etc. Using in using let's say using in and nothing. Using these two operators, it checks memberships. They are great for searching or filtering data. Let's code examples for a job board app checking skill requirements. Let's check job skills. I'm typing skills equal to Python and SQL. So let's write a conditional if Python in skills. Let's print out skill matched. And nothing is similar, but it checks if it is not in skills. So let's write a nothing if C++ nothing skills print skill did not match. Now run the program. It says skill matched, skill did not match. So it printed out two different statements. First one for checking if it's in, and second one for checking if it's not in. Hence, in a job board, this could filter candidates by skills, or you can use things similar to this. And that's the ultimate guide to every Python operator. From pricing orders to securing networks, operators power your code's logic. Try these examples and share in the comments how you are using them. Please do not forget to like the video and subscribe to our channel. Thank you for watching and see you in the next video. In the next video, we will see operator precedence.